Year 2 Week 2 of Mathematics 9. We are now going to proceed with a review first of your lessons from way back when you were in grade 8. So let's start. First, what is 2 raised to 3? You have to simplify the given expression, and this means that you have have 8, meaning 2 cubed is 2 times 2 times 2. Next, negative 1 raised to 2 is equal to negative 1. We have 3 cubed, which is equal to 27. And negative 1 raised to 3 is equal to negative 1. Okay? So this is just a quick recap of what you have before, and I hope it refreshes your mind about what we have to discuss this week. Okay, let us now have our agenda for the week, or today's agenda. First, applies the laws of involving positive integral exponents to zero and negative integral exponents. Illustrates expressions with rational exponents, and simplify expressions with rational exponents. So our first topic would be laws of exponents, and it involves integral and zero exponents, rational exponents, and the radical expressions. Let's proceed with exponents. So we have here an expression wherein 5 is raised by 3. The whole expression is called power. 5 is called the base, and 3 means the exponent. It says here that 5 cubed is equal to 3, meaning we have 3 factors of 5, and that is 5 times 5 times 5. An exponent tells you how many times the base is to be multiplied by itself. Okay? Never, this is the common mistake when working with exponents. They are multiplying the base to the exponent. So most of the time, you got an answer here of 15. But remember, exponent means multiplying by itself. So since 3 is the exponent, 5 times 5 times 5, and you'll obtain 125. Now, let's proceed to the different laws of exponents. The first law is what we call the product of a power, and it can be illustrated through this. A times m, or a raised to m, times a raised to n is equal to a m raised by m plus n. So what did you notice here? If you are going to multiply expression of the same base, all you have to do is copy the base and add the exponents. Okay? Let us have our first example. 2 cubed times 2 squared. This is copy the base, which is 2, then add the exponent 3 plus 2, giving you 2 raised by 5. But this is not the final answer yet. 2 raised to 5 means you have to multiply 2 by itself 5 times, giving you 2 times 2 times 2 times 2, and another times 2, which is 32. Okay? Next, a times a raised by 4. Again, it says here, copy the base and add the exponent. So you'll have 1 plus 4, and the final answer is a raised to 5. This is just like when you were working with multiplication of polynomials. Okay? Next, we have here a squared b cubed divide times a cube b. So equal sign, copy the base 2 plus add the exponent, and you have another base which is 3. Copy the base, then add the exponent, and the final answer is a cube b raised by 4. Okay, let's proceed with another law. And the second law of exponent is what we call a power of a power, and it is illustrated through this. When you say power of a power, wherein a raised to m raised by another power, and the answer would be a raised to n, or raised to m over n. It says here that when you are raising a power to an exponent, you have to multiply the exponents. So when letters or variables are placed beside each other, it means that the operation is multiplication. Let's have our first example. So we have here 2 raised to 2, the quantity of 2 raised to 2 raised to 3, or quantity of 2 squared raised by 3 is equal to 2 raised to 6. Again, copy the base and multiply the exponents, and the answer here is 64. Next, c cube, quantity of c cube equals or raised by 2, you'll have c raised by 6. And lastly, quantity of m squared raised by 4, and the answer is m raised by 8. That's the second law. Let's proceed to the third law. And the third law is the power of a product, wherein if there's 2 or more coefficients inside the variable, all you have to do is to copy the base and distribute the exponents. So quantity ab raised by n is equal to a raised to n, b raised to n. Example, quantity mn raised by 2 is equal to m squared raised to n squared, or m squared n squared. Second example, quantity a squared bq b raised by 3 is equal to a raised by 6, b raised by 3. Okay? You are distributing the exponents by simply multiplying them. And lastly, you'll have 2, quantity 2 s cubed c raised by 4 raised by 2. So this means that you have 2 raised by 2, s raised by 6, c raised by 4, and therefore your answer now would be 4s raised to 6, c raised to 4. Yes, you still have to simplify this. Okay? Let's proceed to the fourth law of exponent. And the fourth law of exponent is quotient of a power, wherein if a is raised to m divided by a raised to n equals a raised to m minus n. Yes, you're right. This is almost similar with power of a product of a quotient, but the only difference is that you are now subtracting the exponent. So always remember that if you are working with quotient of a power, you have to copy the base, subtract the exponents. Let's have our first example. So 2 cubed divided by 2 means 2, copy the base, 3 raised by 3 minus 1. And the answer is 2 squared, or 4. Next, g raised to 8 equals g over g cubed, means g raised to 8 minus 3, that's g raised to 5. And lastly, we have this, 45a squared b raised to 4 divided by 5a cubed b squared. So this is what you will do here. Divide the numerical coefficient first. 45 divided by 5 is 9. The bigger number is placed in the numerator, so you will write the answer in the numerator as well. Then, we have to subtract the base, right? Copy the base, subtract the exponents. But 3 minus 2 is 1. You have to place the answer in the denominator because 3 is bigger than 2. So, para mas madaling tandaan, kung saan mas malaki ang number, doon po isusulat ang sagot. Okay? Then, 4 minus 2. 4 minus 2 is 2. And 4 is written in the numerator, so doon natin siya isusulat. Okay? Therefore, the answer to number 3 is 9b squared over a. And if the exponent is 1, no need to write the exponent, just the base. Okay? Fifth law, we have the power of a quotient, wherein if you have a quantity a over b raised by a power, it is equal to a raised to n, b raised to n. So, you have to copy the base and distribute the exponents. Let's have our first example. Okay. So, let me give you one that is not here. Okay. Let's disregard what is written here. For example, I have 3 raised to 4 raised to 2. So therefore, this is 3 squared over 4 squared, or 9 over 16. Another example, let's have a cubed over b squared raised by 4. And the answer is a raised by 12 and b raised by 8. Okay? And lastly, let's have m over n raised by 4. And you will have m raised by 4 and raised by 4. And take note, there are cases wherein different laws of exponents are used in just one problem. It may be a combination of 2 or more laws of exponents in order to simplify a given expression. Next law is what we call the zero exponents. It says here, a raised by 0 is equal to 1, meaning any expression raised by 0 is always equals to 1. Saan po ba na-derive si zero exponent and how come na naging zero exponent siya? It was derived from the quotient of a power. Halimbawa, we have a raised by 7 all over a raised by 7. Using quotient of a power, all you know that you have to subtract the exponent giving you a raised by 0. But if you have to divide this just be cancelled and that is equal to 1. Therefore, a raised to 0 is equal to 1. That is why the zero exponent was derived from quotient of a power. Okay? Next. Let's have m raised by 0 and the answer here is 1. 12x raised by 0, the answer here is 12. Why? The only coefficient that is raised by 0 is just x. So this part here becomes 1, then 12 times 1 becomes 12. And we have here this. Let's simplify. X raised by 0 is 1 plus 3. And this whole expression is raised by 3, so therefore that is 1. So 1 plus 3, that's 4 times 1, and you'll have 4. Okay, I hope zero exponent is now clear to you. Let us now proceed to the last law of exponent. And we have here the negative exponent. What do we have when we have a negative exponent? So as you can notice, a raised to negative 1 is equal to 1 over a. In mathematics, we do not allow a negative exponent. Therefore, if you encounter a negative exponent, you have to make the base becomes reciprocal and change the negative exponent with a positive exponent. Let's elaborate this. So we have here the quantity negative m raised by negative 2, reciprocal. As you all know, this is over 1. So this now becomes 1 all over negative m raised by 2. Or when you simplify, that is 1 over m squared. Okay? Next, negative 12a raised to negative 2b over 3. This is also over 1. So if you have noticed, not all coefficients here are raised by negative exponents. So therefore, we'll just focus on this one. We'll just get the reciprocal of a raised to negative 2. With that, if it's in the numerator, all you have to do is to place it in the denominator and change it to a positive exponent. Okay? And lastly, we have here c raised to negative 3 over d raised to negative 2. So therefore, both numerators and denominator consist of a negative exponent. Get their reciprocals and you have d squared all over c cubed. Okay, that's the end of our lesson about laws of exponents. I hope everything is clear to you now, and I hope you were able to understand all 7 laws. Okay, see you on the next video. Thank you.